We've already seen that relative extrema occur anytime we go from increasing to decreasing slope, we get a relative max, and decreasing to increasing slope, we get a relative min. Now we're going to switch gears and talk about absolute max and min. So the absolute maximum is the highest y value of the whole function, not just relative to the points around it. Same thing, absolute minimum is lower than all points around it, not just the ones near it. It's lower than all the points. So we can use that here, and we'll find absolute extrema, the lowest and highest points of all, by doing kind of the same thing as before. First step, find the critical numbers of the function. So we're going to take the derivative and set it equal to 0. And this time it'll be the first derivative because the first derivative tells us extrema, as well as increasing and decreasing. And then the second step is actually a lot easier than before. We want to compare the y values of the critical numbers to the y values of the endpoints of the end behavior. So we don't necessarily need to make a sign chart anymore unless we're not given endpoints or end behavior. And we'll see that in a second. And we just want to remember the highest y value that we get when we compare our critical numbers, where those relative extrema are, to the endpoints. The highest y value, we're going to call that the absolute max. And opposite there, the lowest y value, we'll call it the absolute min. So that's why every time we've labeled extrema so far, I always put a relative before it, because it's not just a max, it's a relative max. But now we also have absolute max. So we always want to specify what we're talking about, relative or absolute. So again, it starts off the same way to find the absolute extrema of x squared minus 4. I might want to note that this is a parabola, so that can kind of tell me what the picture should look like. The derivative of this is just 2x. I'm going to set that equal to 0 to find my critical numbers. And we'll do 0 divided by 2 is just 0. So there's my one and only critical number. It makes the first derivative 0. And normally I would just compare that y value to the y values of my endpoints. That would be my second step. I would plug in f of 0 into the original function, and I'd have 0 squared minus 4 is minus 4. And I just compare that to the endpoints. The highest one is the max, the lowest one is the min. If you are not given endpoints, like this one has an interval, we have endpoints to test. We don't have that here. We need to figure out the end behavior. So one way to figure out the end behavior would be to just draw a picture. We know this is a parabola. So that might help us figure out the absolute max versus absolute min. But a definite way that we all should know how is we'll have to make a sign chart. So normally with absolute extrema, you don't have to make a sign chart unless you're not on an interval. So here I am going to put my critical number 0 in there. I'm going to label it because it's important. This makes f prime 0. And now I just want to figure out the end behavior by plugging in values before 0, so I'm going to choose -1. Into the derivative, 2 times -1 is -2, so I get a negative value. So I'm decreasing before 0. And then if I plug in anything after 0, plug in 1, 2 times 1 in that derivative is positive. So I go from decreasing and I switch over and I am increasing. So I do have a relative min, kind of what I expected because I knew it was the shape of a parabola, so I get the shape I thought I had. But this is a surefire way to check your work just in case you don't remember what pictures of graphs look like from algebra. So I have a relative min at 0. To find if that's the absolute min, I just compare it to my end behavior since I don't have endpoints. So we drew this picture here and again up here. I want to compare my relative min to my end behavior and see if it's actually lower. So I'm looking at what's happening at my endpoints. My left endpoint is going up to infinity, and my right endpoint is also going up to infinity. So definitely that relative min is my absolute min. Absolute min is at the point 0, -4. But I want to find all absolute extrema, so my absolute max, I want to compare my critical number to my endpoints. Well, that critical number is a relative min, so it's definitely not going to be my absolute max since it's a relatively low point. So I'm looking at my end behavior and seeing what's happening, and both sides are going up without bound. So there is no absolute max. It's increasing without bound. They're both going to infinity, so I don't really have a point to say where it's going to stop and have an absolute highest point. It keeps going up without absolute bound. So try the next one. Pause the video if you need. Let's compare the work. So I'm going to take the derivative, set it equal to 0 in my first step. 2x equals 0. My critical number is still at 0. This is the same exact function as above, but now I want to do the two steps that I really am supposed to. Step 2, I'm supposed to just plug in the endpoints to figure out the end behavior. So that's what I'm going to do here. So after you find your critical number, you plug it into the function. The original function, 0 squared minus 4 is minus 4. And I just need to compare that to the endpoints. So my endpoint before that is f of negative 1. So I'd have negative 1 squared, which is 1, minus 4 is negative 3. And then plug it to my upper endpoint, f of 3, which is 9 minus 4, I have 5. So after you compare your critical number to your end behavior, you want to determine the highest y value is the absolute max, and the lowest y value is the absolute min. So I want to label these. My absolute max on this interval is definitely here. So right, absolute max is at the point 3, 5. And the absolute min is at my critical number. That relative min from my sign chart above is also the absolute min. So my absolute min is 0, negative 4. So the idea is with these ones, we are looking not at an entire graph, not at the entire parabola. Instead, we're just looking at like a little screenshot. We're looking from just negative 1 to 3. And we're saying on this interval, what's the absolute max and absolute min? So as long as you're on an interval, you're guaranteed that you'll have at least one absolute max and one absolute min point. And we found those here.